Shall we start now? How many of you have done sheet? Everyone. Do you have any doubt in that? Okay. Let me see the questions. Okay. The question is, x is equals to t square minus 4t plus of 3 at t is equals to how much? 4 seconds. This is the question, no? Okay. You are the new one today? Chalo, start karte hain abhi. Now, okay, stop laughing. And one more thing. So, this is the question number. What is the question number in the sheet? 23. So, 23rd question in the sheet. Sheet first or second? Second sheet. Okay, now, what he asked you to calculate what? Okay, sir. Calculating distance, displacement, average speed, and your average velocity. Now, x is equals to t square minus 4t plus 3. Is that question is correct? Check once. Correct? Okay. Now, first thing we need to find, whenever the distance and displacement or average speed or average velocity is being asked, first thing you should be checking the body is turning or not. To find that, we need to calculate if the velocity is getting 0 at any time. Okay. Now, so v can be written as dx upon dt, or this can be written as t square minus of 4t plus of 3 upon dt. Okay. So, we should be considering velocity is equals to how much? 0. So, 0 is equals to, after differentiating this becomes 2t minus of 4, or t is equals to 4 upon 2, that is 2 seconds. So, body is getting velocity 0, definitely it will be turning back. Okay, then next, what is the next step? Substituting the value at 0 seconds, 2 seconds and given question, that is 4 question. So, at t is equals to 0 seconds, x is equals to, can I say 3? Or t is equals to 2 seconds, x is equals to how much? X is equals to 2. Substitute 2 square minus of 8, that is 4 minus of 8 plus of 3, that is equals to minus of 1. Or t is equals to how much second? 4 seconds. This can be written as x is equals to 4 square 16, this 16 plus 3. So 16 minus of 16 plus of 3, that is equals to 3. Let's substitute this on number line. Consider this as your 0. At t is equals to 0, body is at plus 3. That means t is equals to 0, x is equals to 3. At t is equals to 2 second, body is at minus 1. T is equals to 2 second, x is equals to minus 1. Then t is equals to 4, body went back to 3. So at t is equals to 4, body is here. That means body started from here, moved here. How much? 4 meter. Very good. Again from here to here, 4 meter. So what is the distance here? So distance is x is equals to 8 meter. Obviously velocity average will be 8 upon 4, that is 2 meter per second. Okay, and displacement is 0. So average velocity is also 0. इतना easy question नहीं आया तुम लोगों को? Okay, right now. Okay, tell me the next question. Question number in sheet 29. X is equals to t cube minus 60 square plus 90 plus of 2. Okay, then next, find average speed and distance. Okay, at t is equals to what? T is equals to 5 seconds. Okay, now listen to me. Now this time the equation is given in cubic form. Now, definitely whenever the question is quadratic or cubic or anything, first thing, if distance and displacement, velocity and average speed, the question is on these things, you should be checking first the turning point. Body is returning to its path or not. That means we need to check first velocity. So velocity is equals to dx upon dt, or this can be written as t cube minus 60 square plus of 90 plus of 2 by dt. Lakshmi, tu maar khayega abhi. Okay, now, so v is equals to what? 0. 0 is equals to, this becomes 3t square minus 12t plus of how much? 9. Or can I take 3 as common? If I take 3 as common, this equation becomes t square minus of 4t plus of 3, which is equals to what? 0. Or now this equation is quadratic. Can we convert that? Yes. बचपन में करते थे ना, 1 into 3 3, 3 into 1 3, or 1 plus of 3 3. We should be getting minus 1. That means minus 1 into minus 3 becomes 3, and if we add it becomes 4. So this can be written as t square minus of 3t minus of 1t plus of 3 is equals to 0. Taking t as common, t is equals to, t into t minus of 3. If I take 1 common, barabar likhana re. Okay, over here nothing is common, so minus 1 can be taken as common, so t minus of 3, which is equals to what? 0. So t minus of 3 and which is equals to 0, or t minus of 1, which is equals to 0. So t is equals to, can I say 3, t is equals to, can I say 1. Both time is positive. Now listen to me. If both the times are in positive, if the both time is getting what? Positive. Two options we are having now. Either the object is getting t is equals to 1, velocity 0, or t is equals to 3 second, velocity is getting 0. Okay, both are positive. Take both to apply method to always. Okay, then if one is positive and one is negative, always neglect negative values. Reason, time cannot be in negative. Okay, now, so the same equation, t is equals to, that means can I write x is equals to v dt, integrating this. Okay, now from what time to what time? First thing, starting from 0, and first time is getting what? 1. So 1 plus of v dt, then the second velocity is getting 0. That means this can be written as 1 to 3 plus of integrating from 3 to 5 v dt. Now, why I am writing like this? First thing, when is the first time velocity is getting 0? At 1 second. Okay, that's the reason I separated this value first. That means 0 to 1, how much traveled. Then next, body is stopped at 3 seconds. So from 1 second to 3 seconds, what is happening? Then the third is 3 to 5. This is the final time. Now, x is equals to v. What is the value of v? Here is the value of v. So, integrating 3t square minus of 12t plus of 9 from 0 to 1 plus of 3t square minus of 12t plus of 9. This is also integrating from 1 to 3. The next is what? 3 to 5, na? So 3 to 5, 3t square minus 12t plus of 9. Okay. So x is equals to, this becomes 3t cube, so t cube minus of 60 square plus of 90, 0 to 1 plus of t cube minus of 60 square plus of 90. Again, this limits are 1 to 3 plus of, again, t cube minus 60 square plus of 90. Limits is 3 to 5. Apply the upper limit, lower limit, get the answer. Got the answer? How much? Okay, let me check. So, x is equals to, lower limit becomes 0, upper limit is nothing but 1 minus of 6 plus of 9. Okay, then plus of upper limit 3 cube, that is 27, minus of 9 6 54, plus of 9 3 27, and your lower limit is what? 1 minus of 6 plus of 9. Then plus of upper limit, apply upper limit, 5 cube 125, minus of 25 into 6, that is 150, then 9 5 45, minus of, apply the lower limit, that is 3 cube 27, minus of 6 square 9 9 6 54, plus of 27. Okay, solve this. So x is equals to, this becomes 4, then 27, 54, and this get cancelled, 27 27 54 54 plus of this 54. So this get cancelled. Similarly, can I say in the denominator also it can cancel? Yes, in the denominator this also gets cancelled. So minus of, next is minus of 4. Whenever the minus 4 is coming, you have to substitute the magnitude. Then plus of how much? 20, plus of 20. Now tell me the distance. Distance is nothing but, all we need to add this one while considering the distance cannot be negative. So 4 4 8 8 plus of this 20, 28 meters, and displacement can be written as 20 meters, and average speed can be written as 28 upon time kitne 5 seconds, or velocity, average velocity can be written as 20 upon 5, that is nothing but 4 meter per second. How many of you got these answers? Very good. Chalo. Okay, what is the next doubt? Question number 6. Okay, question number 6. What is that? R vector is equals to 2t I cap plus 60 j cap. What he asked? Equation of path. So equation of path is equals to question mark. Now listen to me. Whenever such questions is given, this one is very easy question. This value is nothing but x value, and this value is nothing but your y value. Yes or no? Okay. So can I write x is equals to 2t I cap and y is equals to what? 60 j cap. Or equation we need to write dividing these two. That's it. X upon y is equals to 60 I cap plus, 2t I cap upon 60 j cap. T get cancelled, 2 ones, and this is 3's. Y is equals to 3x. Answer is over. हाँ इतना ही है. Okay. I already explained these things. Now, equation of path, how to find this equation path? Okay, now they can ask you velocity also. What is velocity? Same thing. So velocity is nothing but, can I write dr upon dt? Or this is nothing but 2t I cap plus of 60 j cap upon dt. Yes or no? Okay, differentiate that. So v is equals to, this is nothing but 2 I cap plus of 6 j cap, or in terms of magnitude we can also write under the root of 2 square plus of 6 square, that is nothing but you are under the root of 36 4, that is 40 meter per second. They can ask anything, right on. Okay, shall we now write the next heading? Acceleration, and it is represented by a bar. Okay, now in your previous school level, college, you have understood that acceleration is nothing but the rate of change of velocity with respect to time. So first thing, let me define that. Change in velocity with respect to time. First thing, velocity should be changing. Velocity should be changing. And if I want to write, for example, at this point, point A, and at point B, if the velocity is 20 meter per second, and at point B, the velocity is 30 meter per second, whatever the distance, whatever the time it is taking, final velocity is 30 meter per second. Initial velocity is 10. Let this one is taking a time t1 at this point, and it reached to point B at t2 time. Okay, then can I say this is nothing but delta t also? From A to B, this is nothing but delta t now. T2 minus t1. So average velocity, average acceleration can be written as change in velocity with respect to time. Or this can also be written as v final minus v initial upon delta t. First thing. Okay. So here velocity is the function of time. Now the next thing. Shall I? Okay. Stop writing, guys. First listen, then I will keep the board as it is. Okay, now consider an object is traveling from point A in this direction to point B. Let this velocity is 10 meter per second and this velocity is constant. Velocity here is what? Constant. If the velocity is constant, what is the acceleration? Obviously 0. Yes. So A is here 0. The velocity must and should be changing. If velocity is not changing, then acceleration becomes 0. So can I say that acceleration can have a value 0 when the velocity is constant? Okay. Now, similarly, for example, a body is traveling here. Point A to point B to point C, and let it may be traveling to point D. Initially, its velocity is 5 meter per second. After 1 second, velocity becomes 10 meter per second. Similarly, after 1 more second, velocity becomes 15 meter per second. After 1 more second, velocity became how much? 20 meter per second. Okay. Now, how much the velocity is changing in 1 second? 5, na? So, in 1 second, the difference between these two is 5. The difference between these two velocities is 5, and the difference between these two velocities is also 5. That means, can I say that velocity is changing 5 meter per second velocity in 1 second? Yes or no? What is this 5 meter per second velocity? What is this? Time. So velocity upon time is nothing but acceleration. So how to learn what is acceleration in reality? So acceleration is nothing but how much velocity is changing in 1 second. In this example, how much velocity is changing per second? 5. I got my point. Either velocity is increasing or decreasing, whatever happening, we will discuss that bit by bit. Okay. Now, so acceleration is nothing but meter per second per second. Change in velocity per second. So can I say acceleration's SI unit is meter per square second? Are yes or no? Okay, write down now. Okay, now example number 1. Sorry. A, this is B, this is C, this is D. Okay, at this point let the velocity is 2 meter per second, at this point velocity is 4 meter per second, at this point 6 meter per second, at this point 8 meter per second. So in 1 second, how much velocity is changing? 2 now. So in 1 second 2 meter per second velocity is increasing or decreasing? Increasing. So can I say that acceleration is nothing but 2 meter per square second? Okay, 2 meter per square second. Now first thing, what is the difference between 2 meter per second, 2 meter per second, 2 meter per second and 2 meter per second? What is the difference between these two? Yes, this one is moving with constant velocity, that one is increasing velocity. I am asking one more difference. What is the main difference? What you can't see here? Yes, distance. Here, from here to here distance will be x, from here distance will be x, and from here to here distance will be x. Consider in each second, 1 second, 1 second and 1 second. But can I say that in this 1 second, let this distance be x1, and in this 1 second, let this distance be x2, and this distance is x3. Again, the time period is 1 second. Can I say that x1, x2, x3 all are equal here? No. Who is greater? Who is smaller? Yes, x3 will be greater. So can I say that x1 is smaller than x2 will be smaller than x3? Why? Because v1 is greater than v2 greater than v3. Okay, now whenever velocity is increasing, distance also increases. Why? Because velocity is a function of time t, or x is also function of time t with velocity. Okay, now can I say that if I am writing, we got positive acceleration or a negative value? Positive value. So whenever a is positive, velocity is increasing. Velocity is increasing. Can I also say that displacement is also increasing? Increasing. Then acceleration is a vector quantity. Why? Because velocity is a vector quantity. Velocity is a vector quantity. Can I say that? Then what will be the direction? Whenever acceleration is positive, velocity is increasing, yes. Displacement is also increasing, yes. But what is the direction of acceleration? In reality, where is the body moving? Body is moving in this direction. Or yes or no? Then acceleration direction is also along the direction of motion. Okay, now one more time. Whenever we got acceleration positive, a positive value, that means velocity is increasing. If velocity is increasing, then body will be having some direction of motion. Either the body is moving in that direction, either the body is moving in this direction, whatever the direction is. If the body is moving in a straight line and the body is moving in this direction, and in this direction velocity is increasing, then acceleration direction will be along the direction of motion. So direction of acceleration is along the direction of motion. Aaya kya? Okay, what are the points to remember here in this one? Whenever acceleration here, we got positive, velocity is increasing, displacement increasing, direction of acceleration is along the direction of motion. Okay, right on. Case number 3. Consider at this point A, velocity is 20 meter per second, and at point B, velocity is 15 meter per second. Point C, velocity is 10 meter per second, and at point D, velocity is 5 meter per second. Velocity is increasing or decreasing? Decreasing. Okay, what is the final position? 15. Final velocity is 15 meter per second, and initial velocity is what? 20 meter per second. If I substitute this in equation, A is equals to V final minus of V initial upon time, can I say that 15 minus of 20, that is equals to minus 5 meter per square second? Velocity is acceleration is negative or positive this time? Negative. If acceleration is negative, if acceleration is what? Negative, then can I write that velocity is decreasing? Velocity is decreasing. Acha. x1, x2 and x3. In x1, x2, x3, which one is the smaller one and which one is the biggest one? x3 will be the smallest one. So can I also say that displacement is also decreasing? So whenever acceleration is negative, velocity is decreasing, displacement is also decreasing. If velocity is decreasing, even though body is still moving in this direction, na? So can I say this is the direction of motion? This is the direction of motion. And what is the direction of acceleration this time? Then the acceleration direction will be opposite to the direction of motion. This is the direction. Whenever velocity is decreasing or acceleration is negative, then we call that particular thing as deceleration, or it is also called as retardation. Deceleration, कुछ भी नहीं, D लगा दो यार, DED, deceleration. 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 Okay. Now, whenever the body is moving with what? Decreasing velocity, then the acceleration is what? Negative. If acceleration is negative, then can I say that it is having opposite to the direction? So this is the direction of motion and this is the direction of your acceleration. So always opposite when acceleration is negative. Right on. Okay, now next is acceleration is a vector quantity, na? If acceleration is a vector quantity, it will be having both magnitude as direction. So vector quantity means what? It should be having what? Magnitude, and it should be having what? Direction. It will be having what? Magnitude as well as direction. For example, if I say that a body is moving in this direction by 10 meter per second. Okay, body is moving in that direction by how much? 10 meter per second. Then what happened is body moved in this direction after some time. Now the body is moving in J cap direction. So can I say that this is nothing but 10 j cap, and this is nothing but 10 I cap. Initially body is moving in this direction, so can I also say that this is your initial velocity, and can I say that this is your final velocity? Okay, now tell me what is acceleration. सोच के बोलो. It is having magnitude as well as direction. Yes, but direction is also changing now. We cannot only see the magnitude, we have to check what is happening in direction also. In this example, magnitude is same, but direction is changing. Direction is changing. If direction is changing, then and then also it can be called as acceleration. Okay, how? So can I say this is your final velocity, this is your initial velocity? Initially, this one is moving with 10 meters per second. No change in the magnitude. From here to here, again it is moving with 10 meters per second. No change in the magnitude, but direction is changing. Why? Because acceleration is a vector quantity. Vector quantity means it should be depending on both magnitude as well as the direction. So this time what is happening in this example, only direction is changing, no magnitude change. Even though we can say acceleration is not equal to 0. So in this case, acceleration is not equal to 0. Then what is the acceleration value and what will be the direction? Let us try to understand that. Now, if it is moving in this direction and then later it is moving in that upward direction. So acceleration value is nothing but v final minus of v initial upon time. Na? Yes or no? And I am saying that direction of acceleration is change along the direction, velocity. So acceleration is having delta v's direction, na? Okay, so either the velocity is increasing. If velocity is increasing, the direction of acceleration is along the motion. Just we have checked that. And whenever the change in velocity, then in the next step we saw that decreasing velocity. Whenever velocity is decreasing, then acceleration is having opposite direction to the direction of motion. Yes or no? Okay, now dead bodies baite jaisa baite pure. Okay, now if v final, what is v final? 10 j cap. And what is v initial? 10 I cap. So acceleration is equals to, can I write 10 j cap minus of 10 I cap? Yes or no? Okay, now whenever I am writing like this, and what we got minus of 10 j cap, if I represent that, this can be represented like this, 10 I cap, and this is represented as what? 10 j cap. Soon, initially, this is initial velocity direction, then this is your final velocity direction. Okay, now when we substituted in our formula, what is our formula? Acceleration is nothing but change in velocity with respect to time. Okay, then v final is 10 j cap, v initial is what? 10 I cap. This is formula is negative, na? So this negative is applicable to this, na? Then what is this direction? Negative direction. What is this direction? Positive direction. So what will be the direction of acceleration? I am saying it is along the delta v. Then delta v can be represented here, na? So this is your delta v. Can I also say that this is nothing but the direction of acceleration? Why? Because direction of acceleration is always along the change in the velocity. अबे वही तो बोला ना, ये इधर इसीलिए आएगा बेटा. सुन, यहाँ क्या लिखा हुआ है? -10 j cap. किधर रिप्रेजेंट करेगा इसको? इधर ही तो करेगा ना, कि नीचे करेगा? नीचे तो -10 j cap होगा ना, और इधर क्या होगा? -10 I cap होगा ना. आ गया? Thank you. Right now. Okay, one more. दो कर लो बेटा. Okay, now consider body is moving in this direction. At this point, where is the direction of velocity? Consider this is moving with 20 meters per second. Where is the direction of velocity at this point? Downward. Okay, how to write this one? 20 j cap. Can I say negative? Okay. At this point, where is the direction of velocity? Upward. 20 j cap. Can I say this one is positive? Okay. Now at this point, so again body is moving in this direction by 20 meter per second. At this point here, and at this point exactly upward. Can I say this is nothing but 20 j cap and this is nothing but 20 I cap? Can I? Okay, now can I say this is your velocity initial and this is your velocity final? Similarly, can I also say that this is your initial velocity and this is your final velocity? Okay, now tell me in this one, what is acceleration formula? Acceleration is nothing but delta V. Acceleration direction is along delta V. Now, A is along delta V. In terms of what? Only direction. Now, delta V is nothing but V final minus of V initial. Can I write like this? Okay. V final, upward 20 j cap, minus of V initial, downward, minus of how much? 20 j cap. Solve this. Delta V is equals to what? Nothing but 40 j cap. Aya? Thank you, thank you. Okay, now, similarly in this direction, 20 I cap, this is positive. This is also positive. अरे yes or no? Okay. उसमें भी देखेंगे डायरेक्शन कहाँ है, इधर भी देखेंगे डायरेक्शन कहाँ है. पहले ये बताओ, initial velocity and final velocity. So delta V is nothing but final velocity minus of initial velocity. Final velocity upward, that is 20 j cap. Next this one in this direction, minus of 20 I cap. Okay. Now this 20 becomes, which is in the positive direction. When we return in the change in velocity, it is coming with negative sign. Then if I represent this equation over here, then this 20 I cap comes here and 20 j cap comes here. Are yes or no? And the change in velocity will be moving in this direction. This is delta V and that is nothing but acceleration's direction. Okay, now in this one, minus 20 j cap is moving in the downward direction and plus 20 j cap in the upward direction. And after solving that, we got delta V is equals to 40 j cap. Where is that direction? Yes, the direction is over here. So acceleration is having this direction, that is delta V. Right on. Now listen to me. If acceleration is a vector quantity and it is having both magnitude as well as the direction, that means can I say that both magnitude and direction can change? Then in that situation, can I say at this point, they are considered, here are 4 points. Let A, this is your B, C and this is your D. At A, body is moving with 5 meter per second. Is it possible? Yes. At B, can I say it is moving with 20 meter per second? Yes. Or at C, body is moving with different velocity, let it maybe 10 meter per second. Or at D, sorry, this one is moving in this direction and this can be 20 meter per second. Okay, now listen to me. In this case, can I say that from here to here, consider 1 second. From A to B, taking 1 second. What is the change in velocity? 15 meter per second. And from B to C, 10 meter per second. And from C to D, can I say again 10 meter per second. And then D to A, can I say 20 meter per second? Yes. So can I say that magnitude is continuously changing? At different point, I am having different magnitude. Similarly, at A, the direction of velocity is here. At B, direction of velocity is here. And at C, in that direction. Now tell me, is this a constant acceleration or change in acceleration? velocity is changing, and acceleration at this point and at this point and at this point and between dA, every point, between every 2 point, acceleration is changing. Yes or no? Now similarly, if I say here in this direction 5 meter per second, and in this direction 10 meter per second, and in this direction 15 meter per second, and in this direction 20 meter per second, can I say that it is traveling with a uniform acceleration? Yes, because change in the velocity between these 2 points is what? 5. Between these 2 points is 5. Between these 2 points is also 5. And over here is 15. But till here from A to D, can I say that body is moving with constant acceleration? Yes. So acceleration can be having different values. Either it is moving with constant or it is dependent on what? Time. I need to write this one. Now, for example, listen this carefully. For example, consider here is a pendulum, and this pendulum is hanged here. This pendulum will be moving to and fro. So, can I say that when it reaches to this point, velocity from here to here, increasing or decreasing? Yes, decreasing. So velocity is decreasing when it is moving in this direction. Can I say that at this point, let this point is A, when the bob reached here point A, what is the velocity? 0. Very good. So velocity is 0. Still G is acting. Acceleration due to gravity किधर लगेगा? Gravity नीचे ही लगेगी. So G is acting. So can I say that for a very short instant of time, for a very chinna time, that is dt time, velocity is 0. Acceleration is also 0. No. So similarly, consider one more. An object is been thrown in the upward direction. Object reached to h max, maximum height. At maximum height, when we throw on the object, let it may be u is equals to 100 meter per second, 10 meter per second, 1000 meter per second, whatever it may be. When the object is being thrown, it will reach to the maximum point, and at maximum point, velocity becomes 0, but still G is acting in the downward direction. And how long that object will stay at that h max? For a very short time, that is t is nothing but very short time, that is dt. So can I say that that is nothing but instant time? For an instant. And whenever we are talking for instant, then what is that? Instantaneous acceleration. So instantaneous acceleration is not equal to 0 if v is equals to 0. Can I say that? Here are the two best examples to understand this. Okay. So write a point here. For instantaneous acceleration cannot become 0 or not equal to 0 if velocity, that is which velocity? Instantaneous velocity at this point for a very short time, and at that point a very short time. So whenever we are talking about instant time, if velocity is getting 0, acceleration is not equal to 0. Okay. Consider, here is a book. A book is lying on a table. A book is lying on a table. Can I say for short period of time or for time interval? For time interval, this book will be lying here only, na? Are yes or no? Okay. At this point, what is the velocity? Velocity is equals to 0. If velocity is equals to 0, what is the acceleration? 0. Abhi g to lagega niche, but is there any other acceleration? No, na, which is changing its motion. No. So book lying on the table only. At this point, acceleration is 0. So can I say that acceleration is 0? Acceleration is 0 if v is equals to 0 for time interval. Okay, for time interval, and acceleration is not equal to 0 if v is equals to 0 for instant time, that is very small time. Dimension formula. So dimension formula is nothing but m raised to 0, l raised to 1, t raised to minus 2. Anything left out? What is the direction of acceleration when the object is moving with constant velocity? No direction, because acceleration is 0. If velocity is increasing, direction of acceleration is always along the direction of motion. If velocity is decreasing, decreasing, what is the direction of acceleration? Opposite to the direction of motion. Okay. Write the next heading. Instantaneous acceleration. Okay, now last time ये लिखा हो गया यार, छोड़ो. Okay, instantaneous acceleration. Now listen to me. Instantaneous acceleration is nothing but, we already discussed in instantaneous velocity. So average acceleration को क्या करना है for a short period of time. So whenever we are talking for short period of time about average acceleration, it will be converted into instantaneous acceleration. So instantaneous acceleration can be written as limit delta t tends to 0 or dv upon dt, or this can also be written as a instantaneous is nothing but dv upon dt. Now few things you should be remembering. A instantaneous can be written as dv upon dt. If I multiply and divide by dx upon dx, then can I write A instantaneous is nothing but, what is this? Velocity. So v dv upon dx, sorry dt आना चाहिए इधर. So here can I say that velocity is a function of x, and here velocity is a function of what? Time. Now listen to me. If displacement is given, x is equals to 2t square plus 4t plus of 2. 2t square plus 4t plus of 2. If I differentiate this for the first time, and then this becomes what? V is equals to 4t plus of 4. Yes or no? So velocity becomes 4t plus of 4. If I differentiate this one more time, then this becomes acceleration dv upon dt. Then your answer will be, for how many times I am differentiating this? 2 times, na? So then acceleration is equals to d2x upon dt square. Can I write like this? This means you have to differentiate x 2 times, then you will be getting acceleration. So can I say that displacement is having a function of time t? Similarly, velocity can also have the function of time t.